The reverse bias characteristics of a PN junction diode. You know very well the construction of PN junction diode. It has P-type material and N-type material. In between there is an insulating layer or dielectric layer which is known as depletion layer. So here no charge in the depletion layer. The P-type is majority carriers are holes. N-type majority carriers are electrons. Consider 1N4001 diode. So here we are applying some voltage 0 volt, so there is no change in the depletion region. Now instead of 0 volt I am applying 0.5 volt. So here the P terminal or anode terminal is connected to negative, your cathode terminal is connected to positive. You know the condition for reverse bias, whenever VA less than VK it is known as reverse bias. So here your anode potential is minus 0.5, sorry, it is 0, your cathode potential is 0.5, so your P side is potential is less when compared to N side potential. Anode potential is less compared to cathode potential. This condition is known as reverse bias. So you know very well, so these are the electrons. These electrons are attracted by the positive side of your battery, and it is only for understanding purpose. These holes are positively charged, so these positively charged are attracted by the negative terminal of your battery. So width of the depletion layer is slightly increasing. So the width of the layer is increasing. Now if I increase the voltage to 1 volt, so it is more positive, it is more negative. So in this condition, more electrons are attracted or trapped by the positive battery terminal of your battery, and more holes are trapped by the negative terminal of your battery. The width of the depletion layer is slightly increasing. Suppose if I increase the voltage, the width of the layer is increasing. Instead of 5 volt, if I apply 10 volt, this is the final width of my depletion layer or region. And if I apply 40 volt, almost 80% of your PN junction area will be covered by depletion layer. So the depletion layer is increasing. If I apply 50 volt, then the most of the region is covered by depletion region. So this is the characteristics of a PN junction diode or behavior of a PN junction diode during reverse bias. So when we increase the voltage, the width of the depletion region is increasing. So width of the depletion layer is very high, but the depletion layer gets breakdown. Reverse current will flow through the diode. So let us consider the VI characteristics of silicon diode. If I apply 0 volt, no change. If I apply 10 volt, there will be a small amount of current flowing through the diode. 20 volt, 30 volt, when the voltage increases, when the reverse bias voltage increases, correspondingly the current also increases. At particular voltage, your current is suddenly increasing from microampere to milliampere or from ampere to milliampere to ampere. So there is a sudden increase in current. This voltage is known as reverse breakdown voltage. So diodes start conduct. So in this region your diodes start conduct. So you cannot limit this current because I haven't included any resistance in the given circuit. So we should not operate the diode close to RBVD, the reverse breakdown voltage. Diode will be damaged due to the excessive current flow. So this is the characteristics, VI characteristics of PN junction diode during reverse bias condition. This point is known as knee point. Why it is knee point? Because it looks like, the characteristics looks like our knee. That's why it is known as knee point. The remaining thing, so we will discuss in the next class. So here I have given the definition of reverse breakdown voltage. So please read it.